In this problem, I'm told something about a group of student athletes. There's a bunch who play soccer, a bunch who play track, and a bunch who play neither, and a bunch who play both. And we want to know, based on some of this information, how many soccer players there are. Well, think this through. I don't want to do this with equations. I want to do this just by kind of constructing a logical argument here. If you've got a bunch of soccer players, I don't know, let's just do play numbers. Okay, let's say I've got 100 soccer players and 73 soccer players. Well, does that make sense if you know you have 173 students total? Sounds great. But what about this case? What if there are 20 students who play for both teams? Uh-oh. Right, so we have to modify this little logic diagram a little bit. I'm still going to have 173 students total. But now let's say there are some who only play soccer, and there are some who only run track. There are some who are on both teams, and some who are on neither team. And now these are all mutually exclusive categories. Okay, so that's an important term, and it allows us to use algebra a little more. Because I know someone who only plays soccer cannot only play track, and they can't be on both teams because they're only playing on soccer. So let's fill in the information we know. I know that, 57 students are members of the track team. Okay, well, I don't know if they're only members of the track team. That's kind of tough. I do know that there are 8 students who are members of both the track and soccer teams. That's good. So we're going to put 8 right here. And 94 students are not members of either team. Okay, more stuff that I can put in. So 94 are not on either team. 94 right there. How many of the 173 students are members of the soccer team? Well, you might think you're stuck at this point, but we're not. Let's take a look at that 57 students members of the track team again. Okay, I've got 57 track team members, and there are 8 students who run on both teams. So take this, try this on. Only track plus the number of students who run both equals the total number of people on the track team, right? You're going to have a couple people who run both. We already know that. That's 8. Okay. And I also know the number of people on the track team. Okay, that was 57. There are a total 57 people. Well, what plus 8 makes 57? We can solve this. This is going to be, is it 49? I think it's 49. 49 plus 8 equals 57. So that means there are 49 students who only run track. And when you add them to the students who run both track and soccer, you get 57 students total who run track. So we've got 49 students who are only track. Now we can figure out how many only run soccer. Okay, so that's going to be 173 minus 8 minus 94 minus 49. Okay, looks like the soccer team only has 22 people on it. But combine them together with the people who run both, and it looks a little better than that. So that's how you solve this sort of problem. You got to think about these things in terms of mutually exclusive categories. Only soccer players, only track players. If you're missing those, set up a little baby equation like what I've got here to help you figure out how many are only on one team or the other.